Start recording. Hello everyone and welcome back to Handmade Hero, the show where we code a complete game live on stream. We are coming back off a long and distinguished break. It's been a couple weeks here without a Handmade Hero. Good to see everyone again. And it's good to be back programming with you guys. Now, here is the question. We stopped in the middle of doing our printf routine, and I believe we had pretty much, surprisingly, it went surprisingly quickly, we were able to reproduce like all of printf's formatting and everything else in just a really short period of time, which was great, but I think we may have gotten ourselves down to the point where the only thing we actually have left to do at the moment is floating point printout. So I think we have kind of gotten ourselves into a bit of a bind, because if we want to finish this section of the code and move on, I think we have no choice but to essentially tackle the floating point printout problem, which is a pretty nasty problem. It's not great. It is not great. So let's double check to make sure that that's the case, but I think it is, and so I think we're just going to have to deal with it. Now, we're here on day 328, which of course, if you are wanting to follow along with me, day 327 source code is the source code you're going to want to start with, I believe. Let's double check to make sure that that's correct, since we've been away for a while. I want to make sure we're on the right day. Day 328. Oh, no, that's not good. It says day 328. We need to be on day 329, right? Because there already is a day 328. I don't know why that got set wrong. Okay. All right. So day 328 is the source code then that you're supposed to be starting with here on day 329. And let's go ahead and just jump into the code, because it's been a long time, and we'll probably just need to sort of refamiliarize ourselves a little bit with what's going on. So here we go back into Handmade, do our little build. Everything's building okay, so that's great. We can, you know what, I wonder, so a fresh build is 1.574 seconds, right? What's a warm build? 1.309. So not that much different between a warm build and a cold build there. About 0.2 seconds. Anyway, so let's take a look at what's going on here. I think, like I said, that we have just everything kind of working except for the floating point printout. And you know, you can remember sort of what was happening here. Here's our an example of some code that should have had, you know, some numbers in there, right? But they're not getting printed out. So I think everything is currently getting printed except for those percentages. So you can kind of see here, for example, we're printing out integer numbers just fine in these places, but after these percentages, there should be information there. Same with this millisecond count, same with that millisecond count up there. So right now, I think we're at a point where everything's moving along okay, but we do have to add floating point printout if we want to restore our previously existing functionality, but everything else is fine, right? So I think that's all we got. I think that's where we are at. Okay, so if we go back to our code, I think someone also sent in a bug. I don't remember if they put it into the GitHub or not. I think someone also sent me in a bug or posted a bug on the forums that we had done. There was a mistake in the array count. Let's see, I don't remember where this is. It is in shared. Yeah. Somewhere I accidentally took the array count of a pointer. Yeah, you can see I did it here, right? This was supposed to be array count of the buffer, but instead I did array count of the pointer. It'd be nice if that's the kind of thing we could get warned about, but of course, you know, it's not quite meta-programmable enough in C to really do that. But anyway, that was a little bit of a bug there, so it meant that we would never have, we would only have 8 characters worth of space, because it was taking the length of a pointer, like how big is the pointer, and a pointer is 8 bytes in 64-bit. So it was saying that the maximum we could fit was 8 characters. But we really want to be able to fit a lot more than that in case the number was long, so we wanted to fit 64. So now this will correctly give 64 instead of, you know, of what it was before. So that, I think, is really all there is to that. I don't know, is this temp being even used anywhere? Is this actually, do we even need this? Yeah, okay, so I guess we do. So I can't get rid of it to avoid said mistake, but that's okay. All right. So I think, like I said, that we're in good shape for everything else. So the only real thing that we've got that's a problem here is all of these guys, you know, F, E, G, and A. They all read their floating point argument off of the stack like we want, but then they just throw it away, right? So what we want to do is we want to have something that's similar to the way the thing was working before in the other cases, right? So we've got this U64 to ASCII, and then we're sort of doing some, you know, nonsense with it after. But what we really want to do here is we want to basically have an F64 to ASCII, right? We want something like this. And I don't know why we've got the basis here. I guess that was because, oh, so we could have hex and stuff like that. So we don't really need that because the basis is always known. We'll probably have to pass some other things to this piece of code later. But for right now, I'm going to ignore most of the formatting things here, the F, like what the difference is between all of these guys. I'm going to ignore that for now and just stuff all these guys with the thing which says, hey, let's just get printout working at all, and off we go. Now, A, I don't remember what A is, but I guess it must be some other formatting thing. All right, so we've got F64 to ASCII, right? Let's go ahead and put this in here. And that's sort of the basic piece of information that we need. And we know we're going to print out a floating point number here. Oh, and this should take an actual float, right? So we have a couple problems. First of all, we need to know some more information than just this. Because if I recall correctly, precision we have not really been using yet because we haven't really had to. But we're going to want to pass a precision value here because floating point values, unlike integer values, have this sort of additional concept of a format that says how many things after the decimal point could we print out maximally, right? So in addition to the normal stuff that's going to happen with our number, like the width of it, you know, keeping the width correct and all that sort of stuff, which is about the total printout size, we also have another piece of information, which is that after the decimal point, we may want to restrict how many there are. So for example, in a lot of cases, we'll do something like %.02 or something, which says, hey, we want there to be 2 things past the decimal point, so, you know, keep that in mind, right, or whatever. And so that's going to be important because it does affect how much stuff we print out when we're doing the F64 to ASCII. Now, actually, I don't know that it's that hard to print out when you know what the precision actually is. I mean, there's probably some cases that we would care about that we wouldn't handle quite properly, and maybe the accuracy, you know, there might be some accuracy problems there or other things like that. But I think, in general, the real trickiness is figuring out what the minimum number of digits we would have to print out would be to represent the value correctly. And let me just say really quickly why that is so you have some idea of it. I'm not a floating point guru. So, you know, take it with a grain of salt, but I'm just going to try and give you a little bit of why this is kind of a nasty problem. All right. So day 329, float printing. And maybe we'll say, like, not very good float printing. So here is fundamentally the problem, right? When we were talking before about decimal numbers, what we have is, remember, we have a binary representation of a number for our decimals, right? So maybe our binary representation is like something like this, right? 10011. And then we have a decimal representation of that number that's what we want to print out. Because we don't want to print it out in binary, or at least we usually don't want to print it out in binary. We want to print it out in decimal because decimal is what humans are used to reading. Sometimes we want hexadecimal, other things like that. But usually the point is the base is not base 2, it's base something else, like base 10. Right, so this is base 2, this is base 10. When we want to print out a binary number in base 10, we then have to sort of think about how we converted it, and we were using dividing by 10 as a way to do that, right? So what's this, binary number in decimal? Well, I've got a 1 plus a 2. We don't add a 4. We don't add an 8. We do add a 16, right? So we add these together, and we get 19, right? And so that's like what we want to print out there, right? 1 plus 2 plus 16. And so this printout process, this is relatively easy for us to do because all we actually had to do is go, all right, why don't we just divide this thing by 10 periodically using an integer divide, find the remainders, and print out the remainders, right? And you remember how we did that here. We kind of came through, this is our U64 to ASCII routine. We would just say, all right, whatever the current remainder is base 10, that is the digit that we're going to print. And of course, those got printed out in reverse order because, if you we had this 19 here, we divide by, we look at the remainder, when we divide by 10, we're going to get the 9 first, and then we kind of actually do that divide, and then we look at the next digit, which is a 1. So as we went through the number, we were going in this direction, right? Because we were dividing by 10 sequentially as we went. Okay. So the problem that happens in float, and let me just go ahead and label this side integer here. The problem that happens in float is we have a very different circumstance going on, right? In floating point, what we actually have is we have some concept of where a decimal point is relative to the number, but that decimal point doesn't have to be at the end. So right here, we always knew that the decimal point was going to be after this thing, so we could just divide by 10 and just pick it off as we go. Right? And we knew that we were not really suffering any accuracy loss there, right? There was no real concern that we would get like incorrect answers by doing the divide by 10. It's just, it's a perfectly safe thing for us to do, looking at the remainder mod 10. Now in floating point, we have a different circumstance. In floating point, we may still have a thing that looks like this, but we may be told that the decimal point is effectively here on it, right? Because remember how floating point numbers are encoded, they have a thing like this. It kind of looks like this. We've got a sign bit, right? So we've got a bit that says whether it's positive or negative. We've got an exponent, right? And the exponent says what 2 to the what power this number is going to be. And then here we've got a mantissa, which is the actual thing that will be multiplied by that exponent, right? That will be essentially shifted, right, by that exponent. So it's entirely possible for this exponent to be negative, right? So it can be a fractional value, right? It's entirely possible that this exponent won't be negative, but won't be enough to make the mantissa be entirely on one side of the decimal, on this side of the decimal point. So we can often have a case where the number that's encoded, right, if this is encoded in here, if this exponent isn't enough to push the decimal place all the way to the side, then we're in a decidedly different scenario in terms of what the number means. And the reason for that is because although the part on this side of the decimal point could still be printed out in exactly the same way, the number on this side of the decimal point works kind of in a much more squirrely fashion, right? This, is 1 over 2. This is 1 over 4, right? This is going to be 1 over 8, right? So as these things go, they sum smaller and smaller values kind of going out, as they go, right? So what we kind of need to know there is how many decimal places would we need to print out in order to actually capture this value, whatever it is, right, in decimal, is something that's a little bit tricky. So if you think about what's going to happen here, first we could try to break this problem down, right? We could try to say, well, it's pretty easy for us to remove the part of this number that is fractional temporarily. So it's probably free if I want to just architect. Again, not trying to do a particularly good job here. I'm just trying to walk through the problem so you can kind of see me like try to fuss with it and maybe get a better idea about why it's kind of tricky. But I can remove this part of the problem if I wanted to, right? I could probably find a pretty simple way of just taking the fractional part of this number. And in fact, there's actually library routine already to do it, but we would probably want to write it ourselves. But I believe there's like a fract. Is there fract these days in C? Or is there not? Let's take a look. Yeah, here you go. So if we want to, fract I think is the one from the shader languages. That's what I'm thinking of there. But so if you want to, for example, right, we can make a call to the C runtime library. We could also imagine ways of us doing this ourselves, right? Where we can split a number into its fractional and non-fractional parts, its whole number parts. So if we want to, we could call mod f, for example, and mod f would do that split for us. And then we would be able to print out the integer part separately and know that we were left only with the part that we actually wanted. And you can also see how we would probably do that in terms of doing this directly ourselves. Since we know what a floating point number looks like, we can certainly do work with the exponent ourselves, right? So we could certainly say, well, whatever the exponent value is, if that exponent value is not if that exponent value is 0 or negative, then we know that all the bits are fractional, right? If that number is greater than the number of bits in the mantissa, right? If it's going to push it further out than the mantissa, then we know that the entire thing is going to be the non-fractional part, and we just have to shift it up by however many places we would need to based on the exponent, right? And so the only thing we really have to handle is the case where it's right in the middle, right? Where it's something right in the middle. Even so, it'd be pretty trivial for us to do this just in C by actually casting it to an integer, right? Like removing the floating point part of it, casting it to an integer, and doing like a subtraction to remove the integer part, and then we're left with just the fractional part, which we can then subtract from the whole thing to give us just the integer part also in a float. So you can even see like ways we could do that pretty trivially. So if we wanted to, we could probably remove that part. We could probably make things simpler by getting rid of this thing. But we would still be left with something like this, right? Where we have to figure out a way to print this out. Now, if you look at what happens here, we've got 1/2, 1/4, 1/8. If we want to sum these together, it's kind of a pain in the butt still, but we can do it, right? We would want to multiply this guy by 4/4, right? So we would have 4/8. We would want to multiply this guy by 2/4, right? I believe. So we'd kind of go, right? And then we would want to multiply, 2/8. And then we would not multiply this guy by anything. So basically just making a common denominator for this guys, we would add them up and we get exactly what you would expect, right? 7/8. So you can kind of almost see how that process works. It's sort of just the exact same process that we were going through up here. Each bit is contributing a number to the top, and then the divisor is just whatever the furthest out bit was, right? It's pretty straightforward. Anyway, if you take a look at what happens here, we ended up with something like 7/8. So the number that we would want to print out here, 7/8, looks like that, right? So we want to print out 0.875. But the question is, how do we get there from the floating point representation? Right? Well, we could, in theory, again, if we're trying to do a not very good one, so we don't care about all of the destruction that will happen to our number. And for Handmade Hero, it's probably fine, right? Because this isn't a project about printing out floating point numbers accurately, and like I said, that's really difficult. But for our purposes, what we could do is say, well, all right, if we know how to print out things when we have them in the whole number, what we could do is just multiply this number by 10, right? That would shift the fractional part over 1 And now we could look at the integer part and print out that integer part. And then after we're done with that, we can print it out by 10 again and look at the next digit, right? Because we know how to print out that first digit. It's just mod 10. It's just the number mod 10, right? So if we just keep shifting digits periodically over until we don't feel like there's any digits left, that would be one way to do it. Now the question of when there's no digits left is kind of a little bit of an open-ended thing still, but you can see how that would work, right? So let's start by just trying to approach the problem in that way, right? Let's start by removing the fractional part by taking the integer part and printing that out the way we already know how to do it, and then printing out the fractional part by just shifting it up by do multiplies by 10, just shift it up into the integer part so that we can just print those out sequentially as well, right? That seems like a relatively straightforward way to do it. Now again, not the best way to do it probably, because as we're doing those multiplies, we are losing floating point precision potentially there, and we may destroy bits that we actually need. This is why printing out floating point numbers is tricky. But if we just want something that basically prints out floats without a lot of fuss, then it's probably not a huge deal, right? Okay, so let's see what we can do. Now, first of all, it looks like we're not handling negatives here, as far as I could tell. So I assume we're handling negatives kind of more at the front end. Now, I don't know where that's actually getting handled, so I'm a little confused about that. Let's take a look. So that's actually here. That's getting handled here, where we do the prefix negative, positive, or this. Now, I don't really know where we want to handle that, but I think I'm going to put it up in here for now. So what I'm going to do first is I'm just going to say, all right, if the value is less than 0, I'm going to want to outchar a negative, and we'll sort of work on the formatting parts of that later if we want to, right? So I'm going to output a negative in that case. And then I'm going to take the value and I'm going to make it positive. So now we know we don't have to deal with negative numbers anymore because we printed out the negative if there was one. And then we flip the sign to clear the sign bit. So now we don't think about the sign bit anymore, right? Okay. So now we do have a slight problem, which is that we know this number is going to be reversed. So really, I suppose if this whole string is going to get reversed, we need to sort of do a thing like we did before, where we remember whether the thing was negative or not. So is it negative? Is it not negative? And only at the end would we do the actual printout. So we'd still want to do the negation, but we don't want to print out the minus till the end. Because remember, we print these out and then they get reversed, I believe. Let me double check. Maybe they don't always get reversed here. I think we had the ability to do either, but I think we want to keep that ability. Yeah, I think we do want to keep that. We want to keep that ability for this because we're going to print out the integers in the wrong order. So I think we want that, right? Although the ones after the decimal place will be printed in that order, right? Because as we multiply by 10, we're printing them individually. So this is kind of a bummer, right? Because it means we have some that come in the reverse order and some that come in the forward order, which is a real pain, right? That's not fun at all. But I guess we'll do what we can. So if that's the case, let me take a look here at how we were doing that, because I think we do, like when we do strings, we had to do reverse equals, yeah, there we go, reverse equals false. So what we could do is we could say for these guys, we don't want reversal, because since, you know, in fact, how many people have reverse equals false? I guess all of these guys do, so that's fine. At this point, it's probably easier to just put reverse only the cases that we actually care about. So since in this case we're going to have to do the reversal ourselves, that also kind of suggests that maybe the U64 to ASCII should be the thing that does the reversal. I'm going to put a to-do here. To-do. Put reversal here instead. Seems like it makes more sense to just go through and flip them. Anyway, F64 to ASCII, here we go. In this case, I can revert to doing it sort of the cleaner way. If we know that we don't have to worry about the reversal case, if it's negative, then I can just print out the negative first and put the value in there. as a positive. So then what we want to do is we basically want to just do a U64 to ASCII, right? And it's going to be backwards for now, but we'll deal with that in a second. So if we do a U64 to ASCII, we're going to want to do the same stuff here. We're going to want to pass the desc. We're going to want to paste the value. We're going to want to print the base we know is 10. And the digits, I don't know where our digits are. I assume they're in here somewhere, but I don't really know. Where are my digits at? Where are my digits? Well, they're going to look like that, right? There they are. So I guess I should kind of come out here and just say, okay, yay, here's our chars. We want our deck chars here. Deck chars. And that should be it. So we'll print out in base 10. That will advance us to the point where well, I guess I should say, we first have to actually produce that number. So I'm going to say, let's get the value integer part. And in order to do that, I think all I really have to do is say, well, give me whatever the value would be in integer, right? Because that's going to truncate the value, which is exactly what I want. It's just going to give me the integer portion. So I think that's enough. And then in theory, I should be able to say, well, now let's subtract away. Let's get rid of that part of it, right? So I should be able to subtract the integer part back off. So here I am getting whatever the integer part was without the fractional part, then I'm subtracting it off. So now the value is just the fractional part, and I can print out the integer part. So that's fine. Right? So now I've got this fractional part. I need to output the decimal point at this point, and then I need to start printing out characters in terms of the divide. Now what I'm going to do first is I'm just going to pass the precision. Because maybe we'll just only support pass precision. I don't know. But what that means is I'm just going to say, okay, I'm just going to say for however much precision we have, we're going to print out things after the decimal place. And this is, again, pretty straightforward for us to do. There's not a lot of mystery here. All we have to do is keep multiplying the number by 10. So basically, we just take the number, we multiply it by 10 to move whatever would be 1 after the decimal point to 1 before the decimal point. Then we can just print that number out, right? We can just say, all right, give me the integer part. In this case, it's just, you know, a number from 0 to 10. So just get that one integer part. Take the value and subtract away the integer part. So it clears that out, right? And then we just want to print out whatever that integer says in the integer table. You know? So then we just need to actually pass the precision here, which I believe we should already have, right? So here's the precision right here. And we'll have to do something about when the precision isn't specified, but maybe what I'll do for that is I will just set it to a default precision like 6, and we'll call it a day, right? Okay. So let's come through here and actually pass our precision. Precision, precision, precision. Precision, 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 and precision. Okay. So, need that anymore. What we should be able to do now is take a look at this. Now, our numbers are going to be backwards because remember, we did not flip them, right? So to start with, we're going to be a little bit janky. Although this looks especially janky. I don't know exactly why. So yeah, not great. Not off to a good start. But that's okay. You know, we can't always be off to a good start. And this actually looks not totally wrong. You can see that the numbers are flipped, but otherwise it's not, you know, the worst possible thing that happened. However, our precision looks messed up. I think that's just because, again, we're not actually specifying it properly, or maybe we are. I think for some of those numbers we should have been specifying it, so it seems like our precision should have been set to something valid. But on the other hand, it doesn't really seem like perhaps that it was. So I'm not sure what's going on there. We'll have to take a look. I'm going to put this, though. Oh, I got to upgrade my forecoder. Alan already fixed that bug. At least I think he did. I don't remember that happening at work. Right now, our routine doesn't allow non-specified precisions, so we just set non-specified precisions to a specified value. So in this case, we'll just do, well, precision is going to equal 8 or something, let's say, or maybe 6, if precision specified is false, then we'll set it. So then we know our precision is always something. Okay, so let's take a look at the reverse thing that's been going on here, and maybe we can just get rid of that entirely. Because here's what's happening with reverse, right? And I don't really like it. I think what we could do is just say, let's just always print out the number as it is, without the reversal. And then what we'll do is we'll just actually bake the reversal into everything that needed the reversal in the first place, right? So like these things, for example, none of these things needed reversal at all, right? Oops. So that's not reversing, not reversing, not reversing, not reversing. And then when we get up to the things that are reversing, you know, you can see the U64 to ASCII is in every single one of them, right? Here's all the people who are reversing. They're all U64 to ASCII, right? U64 to ASCII, U64 to ASCII, U64 to ASCII. So it seems to me like the smarter thing to do there, rather than being fancy like we were before, is to just do the reversal here. So we know at this point we can track the range. So let's just bake the reversal into this routine and save ourselves some trouble. Here we can, let's see, there is no shared CPP. Oh no! Forecoder, where have you gone? Yeah, I clearly have to update. I must be using it. What version of Forecoder am I even using? I haven't had a crash in ages. Forecoder, tell me your version. 4.0.10. I don't know what I'm on, but I don't think it's that. I don't know what Forecoder I'm on. I'll have to look. I will, but just not right now, because I'm in the middle of something here. Okay, so let's get back to where I was. Shared. All right, so let's take a look at what I was doing there. Reverse equals false. So let's go back to what I was about to do. I think all the rest of this stuff is right. So I'm just going to bake the reversal stuff into here. So I'm going to take reverse, and I guess I forgot to do this on the last pass through. I'm going to remove that entirely, and I guess I can just use, oops, that to ensure that I've gotten rid of all of them. Okay. So I think that is all we need to do for that. And then in here, when I'm going to do my U64 to ASCII, all I need to do is remember where I was. Can't remember what the dest thing is here. What is that structure? There's a structure that we're using. Format dest. Forecoder, tell me where that is. Okay. So there we go. All right. So all I should have to do, if I want to just reverse this thing, is say, well, I've got this format dest struct, right? And I know where it would start. So I could say, like, the start of this thing is here, right? Then when I get to the end, I know the end of the thing is wherever it stopped. So if I want to reverse that, if I want to reverse the order of the things that I printed out there, remember this is one past the end, yeah. But I know how many there were total, right? I know that the char count is just going to be end minus start. right? That's how many there are. So once I know how many of them there are, it's pretty easy for me to just walk through half and switch them with the other half, right? All I have to do is say, well, swap index, equals 0. Swap index is less than char count divided by 2, because I just have to go through half the buffer and swap it with the other half, right? And then I can just say, all right, I need to take, whatever the end is, and I guess I need to sort of pre-step the end back one. So I kind of have to do like, pre-step the end back one, so that's in a legal slot. I have to say whatever, in fact, you know what? I don't even really need the char count, do I? I don't even really need the char count, now that I think about it. All I have to do is say while start is not equal to end. Or rather yet, while the start is less than the end. Right? I don't need the char count at all. Because I have the end and I have the start. All I have to do is just move the end back into a valid position. Right? Read it. Set it to whatever the start is, and then set the start to whatever the end was, and then move the start forward. That should just, right? It should be 2 pointers that just kind of move, swapping the values that they had. I think that would just work, to be completely honest. Yeah. So I think, let's double check that I'm right about that. But I think that's really all we would need to do. I'm gonna just, I kind of want to take a look at the, oh, and hey, probably I should put it in the right routine. It's just thinking maybe we should put it in the right routine. Just seems like a good idea. Instead of putting it in the wrong routine, where it's not going to do what we want it to do, because it's not even working on the right code, maybe we'll put it in the right routine and see how that goes. All right, so there we snap the start at the end in the middle of our loop that prints out the values. Then we've kind of just got this relatively simple situation here that we can use. Okay. So let's take a look at what that does, just to make sure that I wrote it even remotely correctly, because, it's been a long day. Could make some mistakes. Make some mistakes up in there. All right. So let's see what we've got first time through the loop, or first time through the code. So we've got a start and an end. Not particularly interesting. We're literally just printing out the value 0 here, apparently. But that's good. We can test the case of only printing out a single digit, which we want to make sure we get correct, certainly. So here we go. We look to see if the start and the end are different. Of course they are, because end is pointing to one past, where the start is pointing. So we back it up, and now they're both pointing the same value. We read out end into temp. We assign end and start, so we basically overwrite itself, and then we assign start to wherever we read. We then move the start pointer forwards. Now the start pointer is pointing past the end pointer, so we exit the loop. We have quote-unquote reversed it, and off we go. Let's hope that we get something a little bit more complicated here. We didn't, unfortunately. So, oh well. Come on, man. Give me something. All right, fine. I'm going to cheat because I can. I want to see this print out something longer. I'm going to say that the value, I'm just going to use the debugger to set the actual value in memory of value to be something else. So let's say that it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So now when I run this, hopefully, if that debugger actually set that value properly, hopefully when we get the string, we'll get that backwards, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. Which is what we wanted to see. So that's good. So now let's see if it reverses it properly. I'm going to snap a pointer to that. Right, I'm just going to say here's the beginning of the string. So as these things move, we can actually watch it work. I'm going to set that as a char star. And so here we can see the string that we started with. And now I'm just going to go ahead and let it do its thing so I can verify that it's actually doing the swapping correctly. And hey, there you can see in the painfully slowly updating watch window of Visual Studio that they're actually swapping those values, which is what we want to have happen, right? So now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's what we want. So I think that's a reasonable way to bake that in there. That seems fine. So now we can go back to our other problem, which is figuring out why the precision part of our thing was not working properly, like with the dots and so on, right? Okay. So let's move on from there. Now we've got our numbers reversing properly. It looks like they're printing out the correct numbers. We're just not printing out anything past the decimal point on these particular cases. Here it looks like we're maybe doing things a little bit more correctly. That looks like a more plausible printout. So it looks like when we're specifying our precisions, like these are ones with specified precisions, we're only getting 2 things printed out. I have an inkling of why that might be, but I don't know for sure. But anyway, it looks like we're within striking distance. This is not a good printout. I would like to stress that again, because like I said, we're just doing really the stupidest possible thing here to print out these floating point numbers, but at least we're printing out something that's resembling the correct value to some extent, right? Okay, so let's figure out what's going on with our precision there and try to make that work a little bit better. Also, how much time do we have here? 8:58. Okay, so we've got about 15 minutes left before the Q&A. I guess that won't tell me. But I think we've got until, because I started at 8:15, so I think we've got till 9:15. All right. So there's our S64 to ASCII. We've got this precision index, and we want it to be less than precision as we print things out. So and this does appear to be working nominally. Again, I don't think it's particularly accurate, but and I could put it to do here to note that this is not an accurate way to do this. So what we have at this point is a problem with whatever is happening printout-wise here. So the first thing I want to do is I want to look at the debug code to see what I'm actually passing as a precision specifier there. I assume that I'm passing, so I'm passing 02.02f, right? That's what I'm actually passing. And so my question is just, how is the 0.02 getting interpreted? And it would seem to me, and I guess I don't know, but it would seem to me that the width specifier of 0.02 in the floating point case actually doesn't work the same way it works in the decimal case. Like, it's not the total width that this thing should be, it's just the width of the thing before the decimal point, right? So I want to go take a quick peek at the printf formatting specifiers documentation so that I know what even it's supposed to be in that case, because I guess I don't really know what the spec... Oh dear. Oh dear. Chrome? Hello? Chrome? Chrome? You can do it. Alright, maybe you can't do it. Chrome, what is the problem? Alright, there we go. So here are my width and precision specifiers. And yeah, minimum number of characters to be printed is the width. If the value is printed shorter than this number, the result is padded with blank space. The value is not truncated, the result is larger. So I guess the problem is we were truncating the value if it was larger. So I guess I was not really doing what the spec told me to do there, right? Am I right about this? Why am I looking at that? It's not related. Right? So I think that's not what we were doing. In this case, we have width. And in here, we were saying, well, I think we truncate the value if it can't fit in width. Yeah, so I think we're kind of following we're following the wrong specification here, right? We did not do what the width was actually supposed to be. Because you can see here that, okay, if the width wasn't specified, use the precision plus the prefix, like etc., etc. These were supposed to be minimum values that came through, but then we're doing loops that sort of stop if the width is not, right? Like if the width is not sufficient to print them, we stopped. And that's wrong, I guess. We should have kept going regardless of whether or not we have any width left. All we really wanted to do was pad if we needed to, right? Yeah. Yeah. That seems to be the case. So use precision is going to be whatever the size of the thing is. So when we say 0.02, that precision also usually is for floating point values, it means something different. So we probably will even have to sort of adjust this condition here because that's not really what the precision means in the floating point case. Does that mean there's no real way in the floating point case to do the equivalent thing? I don't know. Printf is crazy. The way they do their format specification is kind of nutso. It's really hard to understand exactly how all the things are supposed to interact with each other. But, you know, what are you going to do? Anyway, so if we take a look at this, what that would mean if we wanted to relax that restriction, I think what that would mean is that this use width stuff really would allow the use width. The only thing we really need to do is just make it so that the use width itself is always expanded. We could even leave the code the way it is. We could just make sure that the use width itself is always expanded to include the entire size of the thing if it's less, right? So I think all we really need to do there is say, well, you know, if we need like a computed width, you know, we need to say instead of doing if not with specified, I think what we want to do is say if the use width is less than the computed width, the use width equals computed width. So I think that's probably a little more correct. Now, I don't think that should affect anything. You know, I think that should leave our printouts pretty much untouched, if I'm not mistaken. So everything should be fine here, and it does seem to be, so that's good. So now what we need to do is make it so that this precision here is actually computed differently if it's a floating point value, right? Because floating point values need to have their precision specified in a different way, or rather, the precision specifier for them does not mean that you are trying to box how big the value is. It's talking about the part after the decimal point, right? So that's what precision means in this case. For these, it's the number of digits written after the decimal point, which by default is 6, right? So hey, we set it to the right value there, right? That's what we set it to if it's not specified. Okay. So we will need to record whether or not it's float, unfortunately, I believe. And then we'll have to set that to true for these cases because we have to handle the precision differently depending on which one it is we're talking about. Okay, and so in this case, what we would need to do is say, okay, if we are going to if we were using a floating point number, so the precision was used for that purpose, then what this means is we would always use this value, meaning we would not, so we'd say like, you know, if it is a float or the precision was not specified, then we will use the total size of the thing being printed as the amount to print instead. Okay. So that's looking better, but we still have the problem of that's not looking like it's padding properly. And that makes sense because the width value that we specified, I don't know what that width value is really even talking about at this point? Should it have put a space in front? I don't know. I don't really know if it should have or shouldn't have. I think it should have, but then again, if you read that spec, it kind of makes it sound like it shouldn't. Minimum number of characters to be printed. If the value to be printed is shorter than this number, the result is padded with blank spaces. The value is not truncated if cells are. That doesn't say before the decimal point, right? So it kind of sounds like actually that's the correct behavior. Honestly. Right? I mean, if you actually read the spec, it makes it sound like that's doing the correct thing. And it sounds like, you know, if that spec was actually correct, then really the part that's like doing this stuff, these should really be 5.02, right? Because you want to print out 5 total characters, which is what the width specifier is supposed to be saying. So %0202 is not actually correct. Even though I think that's what I normally use, it makes me feel like maybe that spec is wrong or the normal implementation of printf is wrong. I don't know. But you understand my dilemma there, because, you know, this makes it look like it would be the part before the decimal point and you're specifying how wide that should be, but that's not really what the spec suggests. The spec does not suggest that at all. I shouldn't say spec. It's not the spec, it's some stupid help page, so maybe that's totally wrong. But you can see what I mean. Like, that feels like what I should actually have done to make the correct printout. And I don't know who's right in this case, right? And hey, there you go. Now it's correct. So I don't know what to make of that. Is there a better specification? Is there a better specification for this somewhere? I don't know. The width field specifies a minimum number of characters to output and is typically used to pad fixed width fields in tabulated output where the fields would otherwise be smaller, although it does not cause truncation of oversized fields. The width field may be omitted, or a numeric integer value or dynamic value when passed as another argument when indicated by an asterisk. For example, and it prints that out, though not part of the width field, a leading zero is interpreted as the zero padding flag mentioned above, and a negative value is treated as the positive value in conjunction with the left alignment flag. I don't know. I don't know what to make of this, folks. I mean, I guess I don't care at some level. It's our printout now. We can make the specification be whatever we want, but I was just following the printf format specifiers for kind of a principle of least surprise sort of thing, so that it was just, you know, it's what you would expect. Unfortunately, when I'm reading this, I really don't know what it's supposed to be. But I mean, you can see right here what the expected output is. That 3 would mean 3 characters total if we were to believe what these width specifiers say. And if you look, that is 4 characters, right? So clearly, you know, much as my intuition and having used printf my whole life would have expected, that's not what that value means. Yet if you look at what these things are saying, they're suggesting something completely different. And I really don't know what to make of that. That's very confusing. Is all this documentation just wrong? Are they like not stating it properly? And I don't know. Let's see what Microsoft has to say. Optional decimal number that specifies the minimum number of characters that are output. For more information, see printf width specification. Oh, well, you know what? No, though, since it's the minimum number, I spoke a little bit too soon there. Since it's the minimum number, that could be allowed. It would only be if yeah, so that's fine, because it is allowed to print out 4 if you specify 3. Right? 3 positioned before the decimal point, called width. See, even there, but they're saying it that way. They're saying it that way, and that's not what they mean. Or that's not what the spec seems to suggest. Although here, they say it the right way, or they say it the way the spec suggests it is. I don't know. I'm going to call it for here. I'm going to say it's time to go to the Q&A, because I feel like this is something where maybe people should have an opinion about this separately, and we can maybe take a look at the we can take a look at what people on the internet feel in terms of how we do that, because I don't know what to make of that. I don't know what to make of that. I feel like it's really confusing because it looks like people sort of think both things. I'm not sure who to believe, but there you go. All right, so any Q&As at the moment? Any Q&As at the moment? I'm tired. Looks like the Q&A bot is not working. Does the float printout account for left or right alignment? Yeah, I think it does because it's still just using the same code path. So I think, I believe it would do the alignment for us properly. Let's see if we can verify that. So if I was to do this, I have to construct a case where that actually happens. So if I'm to do this, you can see that this is right aligning the number. So I assume if we wanted to, we could left align that number. How does it do? It's negative. Is that right? Because this requires me to actually remember how you left align, which I never do. Yeah. So it does appear that the float obeys that properly, because again, we're just piggybacking on the same code path, which is, you know, it's you'll note I did not write this printf for like being super performant, because we don't care about the speed of our printf, right? It's a debugging tool. And so I wrote the code so that everything kind of goes through the same path, even if that's slower, because that allows us to implement all these finicky things without a ton of code, right? You could imagine if your mandate was like, okay, printf's an actual serious thing, we're really concerned about how many printfs we're going to be doing, then you probably don't have that luxury. You might have to do things so that you're actually smarter about handling a lot of special cases, and like, oh, this is the one for printing out a floating point number with left alignment, and it's like specific, you know, or whatever. Sherlock93, are we stuck on what something %3D means? I was away. Not really. So we're very clear on what %3D means because nobody seems to be confused about that. The width specifier on integers is just obviously the minimum space that it can take up. So it'll be padded if it's less than that. So we get that. The thing that was confusing is some references on the internet seem to believe or act like when used with a floating point number, it meant how many things before the decimal point, as opposed to how many things total. And so we were trying to get confirmation that that was in fact not true, and that %3f, for example, or %3.3f means 3 characters minimum, not 3 characters minimum before the decimal point. Culverfly, sorry if it sounds rude, but why do you even care about the specs? Why don't you just print whatever you want it to be? I mean, it's your code. Yeah, well, like I said, I kind of just was obeying the principle of least surprise there. I mean, we basically cloned printf, so it seemed like it might be worth, you know, copying what their format stuff was. But no, we don't have to care. right? We are not trying to be a drop-in replacement. We did not, for example, and probably won't, do scientific notation, right? So like technically, if we wanted to be complete, right, we have to actually now go and differentiate between these cases, like G and E and F, instead of calling them all the same. And, you know, I might even say we could probably just do this for now. Is that right? These all read exactly the same thing, right? Yeah. Sherlock 93, as far as I know, %3.3f means 3 numbers before the decimal and precisely 3 decimal numbers. That is not what any of the documentation suggests, right? I was sort of thinking the same as you were thinking. That was my intuition going into it as well. And that is why I was confused when the documentation very clearly did not say that. Right? And Martins is posting that, you know, CPP reference states it as it's a minimum width. And that's what I was seeing, yeah. So it seems like I am, my intuition about what that meant is not correct. So I think the way we have it implemented now is more correct per the documentation. For whatever that's worth. So I think we'll keep it like that. I think we will keep it like that. And Sherlock 93, you are not alone. I think that's what I thought it was too. So, you can program a long time and still be wrong about stuff that you use. It's not uncommon. Happens to me all the time. Insofar as, can you say something quotable for test purposes? Well, I feel like it's hard to say something quotable on demand, right? And 3Y gun, yes, I agree. Minimum width makes it more consistent across all types of printf, which is why I'm leaning towards assuming that the documentation is actually correct. Program Gamer, so wait, is it a behavior problem or a bad spec problem? It's neither. We just wanted to know, because we can do either, right? It's easy for us to support either one. And the way I had originally written the code, I was doing it kind of the way we assumed. But now that I read the spec, I changed it to do the other way so that we go along with the spec. And I think that's probably just the way we should, the way we should leave it. Elvin, do you think it's worth implementing a custom string class that uses a custom heap or allocation and disposition of memory instead of dealing directly with null terminated C strings, talking mostly for tools programming? I feel like that's really a question about the context, and I don't feel like it has a generic answer, right? Shock93, thanks for the stream. Have a good evening going to work. Are you going to stream at this time from now on? Yes, I believe we will probably be back at the 8 p.m. time slot because that was my original time slot. It's the one that's baked into the trailer, for example, and it was only because of personal schedule situations, which I no longer have to worry about, that it was ever moved to 5. So I much prefer it at 8. It allows me to have a more relaxed day. And so it will probably stay there for the foreseeable future. But it doesn't mean we won't occasionally have streams at other times. It just means that they'll probably be at 8 again like they were when it first started. Macielde, is text printing speed interfering with your profiling accuracy in a significant way? So not the printf part of it, but the sort is. And so what we would like to do is turn that sorting off at some point, because we don't really need sorting to be happening on our debug output in that way. So that's definitely the case. Torgdor, what advantages does this version of printf have over the standard library printf? None. It is not meant to be an advantage. It is simply that our mandate for Handmade Hero, as you know if you've watched the show for a while, is to write everything. So we're trying to show, for example, how printf works, just like we wrote a software rasterizer. Is there an advantage to our software rasterizer over using OpenGL? No, OpenGL is in fact better, right? Because it leverages the hardware and it can be faster than we can be. Because it uses the GPU, which we don't have access to if we're just writing in x86 code, so we don't have access to a bunch of the computer. But the point of Handmade Hero is not that we're only writing code when we can write code that's better than some existing code. That's not the point at all. The point of Handmade Hero is to show how all of the code is written. And so our goal by the end of the project is to have literally no libraries at all. We've never we've never actually gone and used a library explicitly. We've always written everything ourselves. But just the fact that we started up compiling in C on a C compiler meant we had the C runtime library being linked to us. And eventually we'd like to get rid of that because we can actually go do some fiddling with the compiler switches and some other things to actually tell it to stop by default including that library that we've had. And so there's a few things we need to do to make that happen, and printf was a big one because we were using printf. So the nice thing now is we can get that off the list and say, okay, now we're not using any library code. And so we're getting close to not really having any library code at all, any C runtime library code at all, which would be pretty great because then we would be literally library free. We've always, like I said, we've never gone and used a library explicitly, but just the fact that we started up in C meant our code was being linked with the C runtime library, and that's still a library. And I'd like to make sure that Handmade Hero doesn't use any libraries when it ships. That was part of the idea behind the program. Long Boolean, right now you are padding with zeros. The spec, at least in one example, looks like it pads with spaces. Actually, we pad with both. It's settable. So if you put a 0 in front of it, it uses pad with zeros, and if you don't, it uses pad with spaces, which is exactly what the spec says to do, is my understanding. Elvin, when is the next Handmade Con? It is November 19th. And you can get tickets right now if you would like. You can just go to handmadecon.org. You missed the early bird special, so you have to pay full price, unfortunately. I tweeted about it multiple times, so you don't say you weren't warned. But yeah, if you go to handmadecon.org, you can buy tickets to HandmadeCon 2016 if that is going to be on your schedule. I am, in fact, going to be announcing some things about that soon. One thing I will say is we're having a job fair this year, which will be pretty awesome. It looks like we're going to be able to have members of the engine teams from almost every major AAA engine that currently exists, and maybe even some some smaller engine teams as well, available for. We're going to have like a reception where you can go up and talk to them and learn about what it's like to program on their teams, and Maybe make some contacts if you, so it's who to send your resume to, who to, hit up for a job when you think you're ready. So that's a pretty cool thing that's coming to Handmade Con this year. That's going to be a big addition that we didn't have Handmade Con 2015. So that's going to be pretty great. I think I think that'd be really great for a lot of people who were wondering. Music Guru, what else is left other than printf that would need to be removed? There's a couple. It's just a couple math functions, I think, like sine and cosine. There actually is no processor command for sine and cosine. That there was actually in the x87. So originally Intel chips, the floating point coprocessor did actually have a function called fsyncos, which actually did compute sine and cosine, but those no longer exist in the x64 architecture. So if you want sine and cosine, or atan2, another common math function we will need, sine cosine, atan2, those are actually you have to essentially write your own code that computes them by using like series expansion, or you basically have to construct a numerical technique that will solve the sine and cosine that you want, that will compute the sine and cosine that you want in a few SIMD instructions. And so we have to write those. That's about it. Like we tried very hard to never really use anything in the C runtime library. So like I said, it's not like we have been leaning on it as a crutch or anything. Printf was definitely the biggest one in terms of amount of code, but there still are a couple tiny ones, such that if we were to remove the standard library, we would definitely get a couple linking errors against atan and that sort of stuff. Now, and in fact, I would suspect that since this is our only pound include now that I know of, that includes something from the C runtime library, I think just doing that compile, you can see what we need. So squirt is trivial because that's in the processor. Round is pretty trivial. Floor and seal, pretty trivial. FAB's really trivial. So those wouldn't take too long. Trivial is probably the wrong word for floor and seal. They're not trivial, but they're easier. Sine, cosine, and atan are a little more numerical in terms of you have to understand a bunch of stuff to be able to do them. So, and round F, floor F, and seal F actually, if you're willing to require SSE4, they are built into the processor now. They weren't built into the processor before. Which is actually, even that's not true. They actually have always been built in the processor, it's just it was too hard to access them. You had to set the rounding mode first to get to them, and it's too expensive to like set the rounding mode, do the operation, and set the rounding mode back. What I mean to say is in SSE 4.1 or something, I don't remember what, they added a rounding function that allows you to specify the rounding mode so that you can floor or seal with one instruction to say, here's what I wanted to do, seal the value or floor the value, right? So... Could you explain briefly why the simple approach of printing floats can lead to precision errors? Yes, it's because dividing by 10 is not a power of 2, right? So what happens is, what you would want to do is, if we were printing this out in binary, it'd be really easy. You'd just shift over 1 each time and print out whatever the binary digit was. When you divide by 10, that doesn't shift the number over by an even number of binary digits. So what happens is the whole number changes. And so when you do that divide by 10, you're changing the whole number, and you're going to lose bits at the end when you do that, right? So if you really want to print out a floating point number precisely, I don't think you can ever issue an actual divide by 10. So I think that's why you need to go use one of the real techniques, like that one that I referenced back before break, and actually read up on how to be more intelligent about how you're printing it out. Like I said, on Handmade Hero, we probably don't need to care about that. It's not the sort of thing that we care about here. but it's definitely the case that if you're trying to print out floating point numbers accurately, this is not good enough. It's not good enough. And you need to have a more specific approach. Will everything be recorded at Handmade Con? Considering what nearly happened last year, I'm a little worried. Again, recording and streaming, we make no promises. We try to record. Streaming, we probably just won't try. I don't think we'll try to get it streamed this year. But we will try to get it recorded as best we can. The only way to guarantee that you get to see what happens at Handmade Con, obviously, is to go to Handmade Con. I mean, it's a conference, that's the point. But obviously, we're trying as hard as we can to record it because I think that's valuable for archival purposes, so people can go see what was said and have access to it. So we will be trying to record it. I probably won't bother trying to stream it this year because it's just too much of a hassle. So we'll probably just try to record, but we will try very hard to make sure we record it, correctly from multiple cameras, so we have some redundancy. Let's see here. Think we're done with questions. I think we are done. I'm going to wrap it up. Thank you everyone for joining me for another episode of Handmade Hero. It has been a pleasure coding with you as always. I'm going to remove that so we're still compiling there. Okay. Thanks for coming back after the break. It's been good seeing everyone again and coding with you. If you would like to follow along at home, as always, with the source code, you can pre-order the game on handmadehero.org. It comes with the source code. I update it every night so you can play around with the latest build. We also have a forum site you can go to if you want to ask questions. We have a Patreon page you can go to if you want to support the video series. We have a schedule bot that tells you when the series will be live, so if you want to keep up with that, it's a great way to do it. We have an episode guide maintained by the fabulous Miblo, who keeps chronological sort of indexes into the episodes that are super helpful for catching up on past episodes, so I highly recommend checking that out. And also supporting his Patreon. He has a Patreon that's listed up there as well. If you enjoy that service, he is the one who makes it happen. That's about it for Handmade Hero. We will be back here tomorrow, same time, same place, 8 p.m. Pacific. Daylight time, I believe, right now. Are we in PDT? I don't think we're in PST. I think we're in PDT, but I don't remember. So come back and join us for, I guess we're done with the printf. For looking at some other finishing stuff so we can move on to game code, because I think we're just about wrapping up sort of our engine stuff. That's about it. Hope to see you guys tomorrow. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.